Hey there, Mr. Weaver here, and this is Topic 9, Lesson 6, Solving Quadratic Equations. Which method? After this lesson, you need to be able to decide the appropriate method for solving a quadratic equation. You'll know you're successful after this lesson if you can use the structure of the given quadratic to decide which method would be easiest to use, other than graphing with Desmos. So let's get right into looking at our 5 methods. At the end there, we have graphing. Graphing, if you have Desmos available, you can always use it. It is the easiest method, but we're going to really focus on the other 4. If you don't have Desmos, then graphing is probably not the best way to solve. So first, let's start with square roots. So when should we use the square root method? This method can be sometimes used, and it's easiest when there is no b term. In fact, if there is a b term, you really can't use the square root method. Or it's easiest to use if you can get to x squared equals a number pretty easy. For example, if you had x squared equals 81, the square root method is going to be your quickest and easiest way to solve. Same if you had something like x squared minus 15 equals 49. That you can easily add 15 to both sides, take the square root, using the square root method. Also, if we have a binomial square equals a number, that's set up perfectly for the square root method. Our next strategy we learned was factoring. Factoring can also just sometimes be used, and it's easiest when you can easily factor it. If you're spending a lot of time trying to figure out what the factors are, or if the numbers are pretty complicated, this might not be the easiest way to do it. So for example, if we had x squared plus 5x plus 6, that quadratic is fairly simple to factor. You could have x plus 2 times x plus 3. The simple factoring, where the a value is 1, are going to be your better options for factoring. If a equals a different number other than 1, it gets a little bit more complicated where you have to, find the factors, then use the box method. It gets a little bit more complicated. So if you can easily factor it, use it. If not, choose something else. In the middle here, we have the quadratic formula, which was actually the 4th one we learned, but this one is very useful. It can always be used. So if you don't want to spend some time determining which way would be easiest, you really could just use the quadratic formula. Okay, it is easiest if the quadratic is already in standard form. So it's ax squared plus bx plus c. Then just plug the values into the equation. If it's not written like that, you might have to do a little manipulating to get it that way, but you could still use it. If for some reason your quadratic is written in vertex form, thinking back to topic 8, that would be one time where the quadratic formula would not be very useful, as it would not be written in the correct format. So for example, 4x squared plus 9x plus 5, already written in standard form, quadratic formula might be the one to use. The next one we learned about, which was actually lesson 3, was completing the square. Completing the square can always be used. However, it is easiest when the b term is even and if everything is divisible by a. So if a is equal to 1, then you don't have to worry about that. But if a is equal to something else and not everything is divisible by that number, then you're going to end up with some fractions or some decimals, which is fine. It's just going to get pretty complicated. So If the b term's not even, or if everything's not divisible by a, completing the square might not be your best choice. So if we had x squared plus 8x plus 5, this would be a fairly simple one to do completing the square, as the middle term there is even, and you don't really need to divide anything by a. Next, we have a few examples, some that I will do, some that you will do. All we're going to do is go through and decide which methods would be easiest to use. For help solving using those methods, go back and look at the lessons specific to each type. So first, solve for x. We have x squared plus 18x plus 81. Which method would be easiest? So I have the things here in the order that I'm going to check. So first, square root. Is there no b term? We have that 18x. There's a b term. I'm not going to use the square root. What about factoring? Is this easy to factor? Yeah. We would get x plus 9 and x plus 9. We could use factoring. Could we use completing the square? Is the b term even? Yep, it's 18. Is everything divisible by a? Yep, a was 1, so we don't have to divide. We could use completing the square pretty easily. For the quadratic formula, is it in standard form? Yes. X squared plus 18x plus 81, that is standard form. So really the only one here we can't use is square root. The other three would be fairly simple to use. So now it's your turn. Pause the video. Which methods could you use to solve this quadratic? Let's check. You should have found that you could use completing the square and maybe the quadratic formula. You'd have to rearrange it first. Okay. Is there no b term? Yes, 4x is there. You can't use square root. Is this easy to factor? It looks like it might be. However, if you test some things out or even use Desmos to find the factors, it doesn't come out nicely. Not using factoring. Completing the square. Is the b term even? Yep. Even if you divide everything by 2, it still works, and after you divide by 2, the b term is still even. So that would definitely be a way you could use. In fact, completing the square would probably be the best way. And then for the quadratic formula, it's not in standard form, but you could easily just subtract 8 and end up with 2x squared plus 4x minus 8 equals 0, and then it would be. Let's look at our next example. We have 2x squared plus 3x minus 8 equals 0. So which method should we use to solve this in the easiest, quickest way we can? For the square root, is there no b term? There's the 3x there, so we're not going to use the square root. Is it easy to factor? This one is not so easy to factor. 2 times negative 8 is negative 16. Is there anything for negative 16 that would add to 3? I can't think anything off the top of my head, so I'm going to say no to factoring. I'm going to cross it out. What about completing the square? If I look right away, the b term in that middle is 3. So I would have to take half of 3, which is 1.5, and then square it, which is going to get a little bit complicated. Plus, if you look, is everything even divisible by a? A is 2. We would have to divide that 3 by 2 and get 1.5 before we can even take half of it again. So completing the square is just pretty complicated. Let's not do it. What about the quadratic formula? Is it in standard form? Yes, it is. We have ax squared plus bx plus c. So quadratic formula would be our best bet here. Use a is 2, b is 3, and c is negative 8, and plug them in. Now it's your turn. One last time. Pause the video and figure out which method would be the best to solve this quadratic? Let's check. You should have said the square root method would be the best, and then maybe the quadratic formula, but probably not. There is no b term here, meaning if we just subtracted that 18 from both sides, we'd end up with x squared equals a number, take the square root, and then we're done. And then just to go through the rest, what about factoring? Is it easy to factor? We'd have x squared minus a number. I'm not exactly sure if we would be able to figure it out. Let's say not easy to factor. So what about completing the square? We need to know if there's an even b term. Well, b is 0, so I guess you could do half of 0 and then add 0 to both sides, but that doesn't really do anything. And even though a is 1 and it's divisible by a, still adding 0 is not going to do much. So let's not do completing the square. So last we have the quadratic formula. We could do this if we subtract 54 to bring it to the left side. We would have x squared minus 36, which would mean we have 1 for A, 0 for B, and negative 36 for C. So we could use it, but the square root is still going to be the quickest way to do it. So in this lesson, we looked at some of the different things that we learned throughout this topic to solve for x and figure out which one is the easiest and best one to use, depending on how the equation looks. Each of the methods has a time when it's easiest to use and a time when they're not so easy or impossible to use in the case of factoring or square roots. So the square root method, which was lesson 1, can only be used when there is no b term. And if there's no b term, then it's the easiest to use. We saw factoring, which we learned about in lesson 2, should be used when our quadratic equation is easy to factor. If it can't be factored, then you can't use factoring method. Completing the square, which we learned about in lesson 3, is a method that will always work. However, depending on the other numbers, it can become pretty complicated to do because it all depends on b. So if b is not even to begin with, either before or after dividing by a, you're going to have to divide it by 2, which can give you some complicated decimals. So if you want to work with fractions or decimals, feel free to do completing the square. If it doesn't work out nicely, feel free to choose a different way. Finally, quadratic formula, which was lesson 4. You can always use that as well. However, it's easiest when the quadratic's in standard form, or you can easily move a number to convert it. If our quadratic was in vertex form, that we learned about in topic 8, then it wouldn't be quite as easy to use. But you could still change it into standard form if you really want to use it. So after this lesson, do you now know how to use the structure, so what does the equation look like of the given quadratic, to decide which method would be easiest other than graphing? And that's the end of lesson 6 on solving quadratic equations. Which method